Hi there, my name is Florian Müller and I'd like to shortly introduce you to some work that I have conducted with my co-authors Martin Schmitz, Daniel Schmitt, Sebastian Günther, Markus and Max Mühlhäuser. In this talk we're going to have a look at how we interact with information on the go, and for that let's start by looking at how we interact with information on the move today. While walking through the city, we see again and again people who stare at their smartphones like zombies. That makes us realize that there seems to be a strong need for constant access to and interaction with information anywhere and any time. And not only are people interacting with and staring at their phones while they are standing and waiting somewhere, but also while they walk around. However, just as distracted driving leads to dangerous situations for the driver and others, also distracted walking can cause people to endanger themselves and others. As a possible solution, head-mounted displays might help us to overcome these problems, as they allow the user to keep the visual connection to the real world while interacting with digital information. However, today's interaction techniques for head-mounted displays, such as gesture-based interfaces or voice-based interactions, are not tailored to the specific requirements of interaction while walking. Therefore, in this work, we explicitly focused on how we can interact with head-mounted displays while walking. For this, we consider a system that displays multiple lanes parallel to the walking path of the user. Each of these lanes represents an option the user can select. If the user continues straight ahead, no option is selected and no reaction by the system is triggered. If the user, however, wants to interact with the system, they can shift their walking path sideways until they walk on the desired option lane. The system highlights the lane the user is currently walking on, and this highlighting is applied to the entire lane. This allows the user to interact with the system without looking down to the floor, as the current state of the system is also visible while looking straight ahead. By walking on a lane for a certain time, the user can select one of the option lanes. This works just as the concept of selection by dwell time in eye gaze-based interactions. In this paper, we analyzed this concept in a controlled experiment and, based on the results, provide use cases and example applications for the future use of such interfaces. Further, we contribute a prototype implementation for the Microsoft HoloLens that implements this style of interaction. If I was able to get you interested, I would be happy if you watch my complete talk on the ACM channels or have a look at the paper. Thank you.